Okay, hi. Assalamualaikum. My name is Nur Zura binti Zulkifli. My metric number is 192225.
Hello, my name is Tengku Nur Ainadia binti Tengku Syafubari. My matrix number is 192436.
Good day, Doctor. I'm Sivan Raj Tyagarajan, matrix number 193765.
Okay, today I'm going to present to you about our statistic project. The title is the time taken for the ball to complete 10 oscillations. This is the materials that we use, which is a rubber ball, ping pong ball, rope, stopwatch, ruler and scissors. The protocol is first, we need to measure the rope at 40 centimeter, and then we tie it to the ball and make sure it is tied tightly, and we need to put it at a high place. Second, we need to lift the ball to a small fixed angle and let it swing to 10 oscillation. When it has completed 10 oscillation, we record the time and repeat it 5 times. Next, we repeat the experiment on 30 cm, 20 cm and 10 cm length. Next, after completing the rubber ball experiment, we use another ball, which is a ping pong ball. Okay, next I pass it to Ain.
Hello, I'm going to explain about this table. This is the table data for the rubber toy ball. This is the first material. We have the time and the period, such as in the screen. Okay, and next is the table data for the ping pong ball. Also, we have included the time and the period. You can see that in the screen. Okay, next is the ANOVA table. From the result that we get from the ANOVA table, the F critical for the sample is okay. From the ANOVA table, the SS and MS that we have calculated is shown here, and we can conclude that the F critical for the sample is lesser than the F, which is reject hash null, and the second is the column, which is also lesser than the F critical lesser than F, so it is also reject hash null, and then lastly is the interaction, which is also lesser than the F, which is also reject hash null. Okay, next is the graph. The first graph is the interaction plot of length of rope versus mean. This is for the material rubber toy ball. It is clearly seen that the graph is slightly increased, starting at the mean of 10, which is about 10 point something, 10.9. Okay, next is the interaction plot for length of rope versus mean for the material of ping pong ball. It is slightly increased from the mean 6 until 10, and greatly increased from 10 to 35 or 36. Okay, next I will pass to the
Alright, okay, now I'm going to continue with discussion. So from the results earlier that we recorded, we can see that the length of the rope affects the time taken. How does this affect? Alright, okay. When the length of the rope increases, the time taken also increases. The time taken over here, we're speaking about 10 oscillations. And besides that, our second parameter is the type of ball. So over here, the rubber toy ball is heavier than the ping pong ball. So the time taken for 10 oscillations is longer because the mass of the rubber ball is basically higher. From ANOVA, we can see that the F value that we obtained is higher than the F critical. If you actually notice from the table earlier, you can actually notice that the F value we obtained was actually higher than F critical. And of course, there will be some errors in our calculation. So highlighting our errors now, the ball does not swing in a single plane. Over here, we are speaking about the ball. Not only it goes in a single plane, it may go forward or backward instead of just left and right. Next, the time taken when the ball complete 10 oscillation is taken at different position of the ball. Over here we're speaking about human error. Now to conclude the entire thing, I'd like to say the different mass gives different time taken for the balls to complete 10 oscillations. In this way, we are saying mass plays an important factor. Next, for the same type of ball, the factor that we can actually see over here is the time that affects the time is the length of the rope. Longer the length of the rope, we will have a longer time taken to complete 10 oscillations. And since our F critical is larger than our since our F value is larger than our F critical, in our experiment we now reject the null hypothesis. That's all from us. Thank you very much.